So previously, we have seen that we were discussing about our very first unit of programming in C, and we were trying to cover up some of the topics. And in the previous three classes, we have covered till topic number 10. 10th one, we were going through it, and today, most probably, we will try to see once more the 10th topic in little detail. But since today is Friday, I'll finish up my class by 1 o'clock. So please excuse me for that reason. And let us quickly jump on to our subject. So we have seen, let us quickly revise back. We have seen that problem solving is nothing but a set of techniques in order to get a solution to a given problem. And in order to get a solution to a given problem, we have 4 steps to be followed. One is we need to analyze the problem. Second is we need to develop a strategy or a plan, which is nothing but an algorithm. Third one is we need to convert that algorithm into the computer understandable language, which is nothing but a coding. So we will use certain programming languages to write the code. Next, once the code is available, we will try to test it out on a computer and we will try to debug if there are any errors. Debugging is nothing but removal of errors. So with that preliminary knowledge, let us move ahead. We know that the algorithms as well as programs, they are two different things. Algorithms are written for human understanding and programs are written for computers. So whenever we are trying to have an algorithm, we know that we need to put that algorithm in terms of understandable format, even to a less knowledgeable person in terms of programming language. So we'll use a flowchart to represent or to depict the algorithm. So when we are talking about the programming languages, we have come to know that there are two types of programming languages, which are high-level language and low-level language. So we have discussed yesterday that whenever we want to do something on a computer, we need to work on the computer's hardware. But we cannot speak directly with the hardware because we cannot talk in terms of electronic signals. Hardware is an electronic device. It requires electrical power supply. We cannot speak in that power supply terms. So we will be converting the electrical signals into ones and zeros. Suppose there is +5 and -5 power supply requirements. +5 will represent with 1 and -5 with 0. It depends on the manufacturer. They will define what type of ones and zeros code are required. Okay, so that language is nothing but machine language. But can we speak in ones and zeros? No, as a human being, we cannot speak in ones and zeros. Not all the words can be translated into ones and zeros. So we have picked up those words which we use very commonly for performing certain operations like adding of two numbers, subtracting of two numbers, or dividing of two numbers, and we have picked those words, and whatever is its equivalent of ones and zeros have been listed out in a dictionary in software called as assembler. So we'll use those nicknames called as mnemonics and we'll write our program. So once we have written the program using nicknames called as mnemonics, we'll pass that program to an assembler to convert that mnemonics into ones and zeros. So that language which was using the mnemonics is called as assembly language. Assembly language program will be passed on to assembler to convert it into machine language, which can be understood by the computer hardware. But how many mnemonics can we use? It's very limited. So in English, whenever we want to communicate with anyone, we want some general purpose language. That general purpose language cannot be just limited one. So in order to have more flexibility to the language, we have gone further ahead to accommodate those languages which are very human understandable. And those languages are called as high-level languages. Usually, internationally, we speak English. So we have those languages called as programming languages, which are high-level languages, usually containing English type of wordings. Few examples of those languages are C language, C++ language, Pascal language, Fortran language, Java language, and so forth. there are thousands of languages available in the market, but basically the languages, programming languages are considered into two types. One is high level, and whatever assembly and machine languages are there, they are considered as low level languages. So we have seen these things yesterday. Now, let me jump to next topic, which we have seen here. We have seen the entire compilation process, how our program is actually written and executed on the computer. So whenever we write a program, we call that program as source code. Whenever we are writing the program in high level language, we call it as source code. So when we are using C language, we will call that particular program and save that particular program as program.c. You can, instead of PRG, you can write anything, use any file name. So whatever program it may be, that's a C program. That C program will be given to a component called as compiler. Since the C program cannot be directly understood by the computer, we need to translate it. In order to translate it, we will pass it on to compiler. Compiler will do is it will try to pick up whatever has been written in this C program. We will not write everything. We will try to use some of the things which have already been already written by some programmers. So instead of writing it once again, we will just try to reuse it up from whatever logic we want to write. So whatever we have written, along with whatever we are trying to use already defined in the preprocessor directives, that will be combined together, that will be converted into a proper format into assembly language. So our program.c will be passed to a separate software called as assembler, and what the compiler will pass it as is assembly code. So our C program has got converted into assembly language code. Now this assembly language code will be taken by the assembler. It will substitute all the mnemonics, whatever are required. And after substituting all the mnemonics, it will generate a code called as system architecture dependent object code. This system architecture dependent object code will be prg.obj. Do remember, this is not completely ones and zeros. This is some intermediary form of language which we cannot read. If we try to use .obj, we cannot read it. Those characters will not be able to be printed. Now, why we are not directly converting into ones and zeros? Our assembly language should be converted into machine language, right? But what happens is, whatever program you have written, that program is fine as per the logic. But apart from that logic, we also require some tools and some utilities which are present in the library files for our program to work together. So this linker will try to link our prg.obj along with the additional files which are required for execution of our program, and it will generate a code called as prg.exe. This prg.exe is completely ones and zeros. This is called as binary file. .exe file is called as binary file. And this can be understood directly by the computer. But when will it be understood by the computer? When the computer is having sufficient memory. And when the computer's processor is free to execute it. So to check how much memory is required for this program and to allocate the memory, we require a component called as loader. This loader will take this prg.exe, allocate sufficient memory to it, and after allocating, it will pass it on to the RAM memory space. Here, whatever memory I have written, in terms of computer, it is a RAM memory space. Okay. Once the program is within the RAM, it can be picked up by the processor whenever the processor is free, and it will take the inputs from the users if it requires, and it will generate corresponding output. So the same sequence I have put it because you have to write this particular question as an essay answer. I have kept it in theoretical points also. Okay, so let me quickly write it down. Compiler is nothing but it's a language processor. It does some processing on the high-level language. It's a processor that reads a complete source program written in high-level language and translates it into machine-level language. So what is a compiler in general perspective? It's a language processor that reads the complete source program, translates it into machine-level language. Now, this source code is translated to object code successfully only and only when it is free from errors. If errors are there, compiler cannot convert it into machine level language or object code. Okay, clear? So once the errors are removed, we need to recompile it out. So whenever you are trying to remove any error, and once you have successfully removed the error, you need to again compile it out. So this is a requirement. Now the same thing is it will take the source code, which is nothing but prg.c, and it will try to substitute whatever utilities we are trying to reuse from the previous developers, which are present in preprocessor directives. Once it has been plugged in, it will check for the errors and generate a assembly level. This is the activity of your processor, sorry, compiler. So after that, let's move ahead for assembler. Assembler is used to translate the assembly language code to machine level language code. So the output, as usual, is machine level language code, which is understandable by the computer. So compiler will take the targeted assembly code, pass it on to assembler, and it will give out to program, which will be passed on to linker. Similarly, I have kept certain notes for loader and linker. So please go through that one. Linker basically will take the assembly level language code, which was program.obj, add on to it some more required library files which are written for OS purpose, and generate a code which can be directly executed on the computer. So loader will pick up that .exe file and allocates in the memory and make sure that proper memory is allocated, and it will pass it on to memory space. That's all is there for today. So the assignment for you people will be explain the complete compilation process, what we have seen till now. So the slides are starting from here. Let me bring it up. This entire diagram you have to draw. Along with, you have to write whatever theoretical points I have written here. Okay. So you need to complete it by Sunday and submit it on your Google Classroom. So from tomorrow, Saturday onwards, I'll start with source code, and inshallah on Saturday we'll finish our first unit most probably. It's simple. Once you have understood with that particular previous one, this is nothing, same thing. Just a few more detailed explanation I have kept here. And then what is the importance of C language and who developed it, that will be a little bit talked about. It's a very vast subject. On Saturday, inshallah, we'll try to finish up our subject. So hopefully I'm expecting the first assignment to be completed and submitted on by Saturday, 5 o'clock. Okay, then thank you everyone. And if there is any doubt, let me just spare 2 more minutes. If there is any doubt, you can just raise it in the chat box, or you can just unmute yourself and ask it. Is there any doubt for? Yes, ma'am.
Sir, what we have to submit, sir, assignment?
You have to draw this particular diagram in your class notes. Read this one along with
Okay.
next slides which we have discussed now. Because whatever I have explained, that's not written in this particular diagram, right? This is just I have explained you. This explanation, theoretical points which you have to write in your exam has been listed here in the next slides. So from
Yes.
diagram onwards till this slide where I have asked you for making the assignment till this point, you have to write all those things in your class notes and you have to submit it.
Okay, sir.
Okay. Is there any other doubt?
Sir.
If there is no further doubt, shall we close off this session now?
Yes, sir.
Yes, sir.
Thank you, everyone.